We're on the last chapter
section.
2.
Yep.
It's pretty short.
Yep.
So I got a couple slides for you here, guys, but that doesn't mean that they're not important. These are very important theorems, and so but it's just titled more theorems.
Yes. Most of these things we've already looked at
Yeah.
in chapter 1. It's just now more of their formal theorem that we're attaching on. So should be more informative than anything else. I mean, it's just so when we do use them in a proof, you have a formal way of saying them in a proof more than anything else.
Right. So we can use these as reasons.
Yeah.
Yeah. This is what you were just saying.
Yeah. So last video I talked about this, that theorem, the right angles congruence theorem, is that all right angles are congruent no matter the size. If it's a little small 90-degree angle that's the size of my fingers, or where the ceiling and the wall meet in your room, that's also 90 degrees, a lot bigger, they're still 90 degrees, so they're congruent.
Always.
And we'll use this a lot. We're trying to compare two right angles, and you can just say all right angles are congruent.
The definition of a right angle is 90 degrees, and so if it measures 90, they all measure 90.
That's right.
So,
and there it is. Even though they're going to rotate it, that you'll know that angle 1, angle 2, because they're both right angles. So
open up.
Yep.
Yep. Congruent subs. Now this one's tricky.
Right.
It's almost like the transitive property.
Right.
Kind of. It says if two angles are supplementary to the same angle. Diagram here.
There you go.
Kind of small, sorry, but if two angles are supplementary to the same angle, so 1 and angle 2 are supplementary to each other. Now you've got to remember what that means. It means they add up to 180 degrees. Okay, so if angle 1 and angle 2 are supplementary, let's just throw some numbers in there. Let's say that angle 2 is 150 degrees. Okay, well, if 1 is supplementary to it, then that means that 1 has to be 30 degrees, right? And then it says those are supplementary to the same angle, so that angle 2 and angle 3 are also supplementary. Well, if angle 2 degrees, that forces angle 3 degrees. So whatever, some examples in there, whatever the numbers are, once you establish what 2 is, angle 2 is, and the other two are supplementary to it, they have to be congruent to each other because they have to add up to 180 degrees. So however far angle 2 is from 180 degrees, the other two both have to be whatever that number is. Okay? So the congruent supplements theorem. If two angles are congruent to the same, or supplementary to the same angle, then they must be congruent.
We really use this theorem a lot when we're trying to solve questions with vertical angles, to where maybe they don't give you the other obtuse angle, and you can get one of the acute angles and then get the other acute angle and then work to find the fourth piece. Sometimes it really works well to understand this idea.
Yeah, we do see that. Yeah. All right. And then of course we have the congruent complements theorem.
Yeah, basically the same thing here, guys. If two angles are complementary to the same angle, then they are congruent. So if angle 5 is 50 degrees, and we know that angle 4 and angle 6 are both complementary with angle 5, then we know, what I said was 40 degrees?
50, I think.
50 degrees. So then we know that angle 4 and angle 6 are both,
40 degrees.
40 degrees. Sorry, I keep forgetting my number. Yeah.
Same one.
So I mean, it's really it's almost the exact same thing as supplements, but instead of adding to 180, we're adding to 90.
Right.
And so, pretty simple stuff. Once you guys practice it a few times, it'll be like, okay, got it.
Yeah.
Yeah.
Okay. Our linear pairs postulate. So again, like Mr. Badillo said, we've built our vocabulary on this already. We've talked about linear pairs. A linear pair of angles is two angles that form a line. And yes, they're supplementary then if they form a line. And so that's what this theorem says. We've said this one. But if two angles form a linear pair, so if they form a line, we know that a line is 180 degrees, then they are supplementary. Okay? Now notice that's a postulate. Okay? So the linear pair postulate, if two angles form a linear pair, then they are supplementary to each other.
And I think this one more helps, though, when we're trying to actually do math with this than anything else.
Right.
So you always know, oh, hey, that makes a line, so I know that's 180 degrees.
Calculate the other one.
Yeah. So I think more than anything else, it helps you when you're doing the math.
Yeah.
Vertical angles congruence. Vertical angles are congruent. So, if you got your arms crossed here, this is the one that just basically says, oh, that's even better, that diagram, that, opposite angles, I like to call them too, because, 2's on top, 4's on the bottom, those are congruent. 1's on the left, 3's on the right, and those two are also congruent to each other, and they're opposites. I mean, the idea that I kind of think sometimes when you look at some of these things, if they look congruent, they probably are, and that's just kind of a sometimes an easier way to help yourself out. I mean, 2 and 4 definitely look like they're kind of similar, so those are vertical angles, and then 1 and 3 are the smaller ones, and those kind of look similar, so those are opposite that are congruent as well. So
vertical angles are always congruent.
Always.
You talk about a basic diagram. It's just two lines crossing each other.
Yep.
Two lines intersecting, and we create two pairs of angles that are congruent.
And to go back to the supplement congruence theorem,
Supplement?
if you look at angle 1 is congruent to angle 2 because they make a linear pair. But then supplementary. So, and then angle 2 is also supplementary with angle 3, so therefore angle 1 and angle 3 are congruent. And that's kind of how you would go about solving the vertical angle congruence theorem.
Right.
If you wanted to do a proof on it, would be to use that idea.
Right.
So, I mean, it's just something to think about.
Yeah. So again, we've pretty much talked about these, but we're just kind of formalizing them in this section, and now we have them as rules, as reasons that we can use in a proof in the next chapter. So that's it, guys. That's all we got for you today.
Yep.
So we're done with the chapter. We're going to be testing and moving on.
Yep.
So we'll see you in class.